specific file will look like inside the CI/CD message. It has like thousands of stars. It's used among a lot of different organizations. So what happened here is someone, I don't know how, but access to the organization that owns this repository. So I think it was called something. So someone got access to this repository, and also got access to this repository, they introduced a malicious change inside of this action, which is used by millions of organizations. And that small change, they didn't break the entire repository, they didn't change much. They only introduced a small change, a small call for a Python script that was dumping secrets inside of the GitHub Actions logs. So that if you are using this and you are using this action in a public repository, whenever you run this through this new action that's not infected, the secrets would be leaked there. So you can see here that you are running this through a CI runner, right? And you are invoking the TJ actions changing files. And the Python script was basically doing those 4 small steps here. So it will download a finding script from a specific path on GitHub, which is even trying to conflict the situation, because if they were download that from another path or from another domain, GitHub would point that as malicious. But they made sure that they would download that from GitHub to make sure it was needed, Then they would execute that script, grabbing for secrets. They would dump all the memory of the GitHub runner. And not sure if you tried that before, but if you try to echo a password or any API key inside of GitHub Actions, it will have just one script, because GitHub has a lot of preventions in place to exactly avoid this kind of situation. But they made sure that they would dump the memory of the process, which is pretty much impossible to catch in this kind of occasion. They would also double encode the secrets exactly to bypass this behavior from GitHub, that whenever they see that a secret is trying to be printed out, they would put wildcards. So they just encoded that so it looks like base 64, right? So that they can see it, and then they decode afterwards. And then they just print the results. And what this did with a lot of companies was that whenever you would run the pipeline after this day, a lot of secrets were made. And that small change all happened because someone got access to the repository and they just introduced a new tab. So people were pointing to V1, let's say, he or she recreated the tab V1, and then you will be leaked. You were using this specific action one day. The other day it was leaked as a new version, and your information will be there. So here you can see all the context of the attack, and this is one example that could fall into the first step, which is someone got access and introduced a exploit into a public used GitHub Actions.
Awesome. And here we have another stuff that we talk about, like we maintain the open source. And if you search for this attack, we have a lot of articles about it, and it's kind of crazy because the way that some attackers are approaching is like, hey, I want to contribute to the project, and the maintain it's kind of burning out because it's just one guy maintaining the whole library. And he was like, oh, it's good, it's really cool. Someone want to contribute to my project, and sometimes it has some problems because of the sustainability of the open source project. So if you search for it, we have like a lot of core libraries that are open source, just with 1 or 2 folks maintain. So definitely it's one of the point of failures about open source. So it's not like it's not a fault from the guys from open source, but it's a problem in the way that we are currently maintaining the open source stuff. So if you look in our application, you will see something that it's maintained by one guy from Ukraine, or like, I don't know. So definitely something that we need to be aware of it. And we have a lot of other scenarios that it's like the same approach, like this one maintaining, and some guys want to contribute. So it's definitely something that is important to mention here.
We had some examples before. Did you go back? Yeah, please. The other one. So the solar meets here, for example, it was very similar to this one, but instead of I said on the first one, I don't know how the driver access, and based on what we read, it was some kind of error in the organization of this specific open source library. But for this one, it was very similar. But instead, the guy started to contribute to the project, and after 3 years contributing, he introduced the malicious change. So can you see that he was there for 3 years, building the relation, building the reputation, so that after 3 years and possibly hundreds of thousands of commits, he then introduced something malicious. So this is something that can happen even with Linux right now. We have a lot of people taking a look on how all the commits and PRs are open, but it's very hard to make sure that no one, because everyone can simply contribute code there, it's very hard to make sure that no malicious code will be abused. So hopefully after this call, we'll provide you some tips on how to avoid this type of situation, but it's something that's always there. And even if you think about all that geopolitical context that we are right now with a lot of wars, the wars that are happening now are different. There's still making many in the world, of course, but both of the wars happening right now between the US and Russia, for example, are science groups. There's a lot of missions who are not about to hijack periodic and US and vice versa. And of course, I don't want to go into the political discussion, but what I'm trying to say is that the world today is different. And cybersecurity is boiled to 10 ways that also to attack an issue, a company, or do not, I think, versus this thought.
So now finally we'll talk about Falco. So Igor, someone here knows why is Falco using Falco or this thing, right? Two guys, yeah, good, got it. Yes. So our idea here is to talk about Falco and how can analysts detect this kind of attacks and maybe respond this kind of attacks with some others tools that are inside the Falco ecosystem. But for today, we will focus basically on Falco. So we want to talk more about it.
Yeah, Falco is a CNCF budget. Of course, you will hear about CNCF, right? It falls under the category of run-night threat detection software. There's a lot of software that does this today. Liz was thinking about Tetragon, which is a software in the same category as Falco. It utilizes eBPF kernel modules to detect behaviors inside worker nodes, and actually any Linux mode. So what Falco is doing is basically detecting syscalls, which is usually the lowest level possible of an action inside the Linux node. So by detecting syscalls, you are basically detecting everything. It's of course very verbose, because you won't be detecting, oh, someone hijacked my phone. You'll be detecting that someone triggered a cat inside a specific path on the file system. So it's very cumbersome to read the data, and hopefully the actions on the wrappers that we have on top of Falco will be helping you to do that. But it's a very low level software to begin with. It's oriented to rules, so all the things that you must use and configure in Falco will be what we call rules. So you have a rule, for example, saying whenever someone reads a specific path on the file system, I want you to be notified. Whenever someone creates a new working directory or a new path on the file system, I want you to be notified. Whenever someone opens a socket in a specific TCP or UDP port, I want you to be notified. And propose low level in small pieces to get started to use a very logic, complex workflow. It can be extended by plugins, so you can actually set up just Google for syscalls. You can collect data from other data sources, have AWS, GCP, Azure, and a lot of different probable data sources. And it was created by SysLib, which is the company that we work for, and it's right now a Broadway version on CNCF.
So we have Falco. You can take a look later on the documentation in how to install it, because like it's basically a binary that you can install it. And the core piece of Falco is because you can customize the rules. So, which like, for example, like you said, I want to be notified if someone tried to open the etcb shadow file, for example. It's something critical for me. It's all to be notified in real life. If someone is trying to open or to read this file, for example. So, this kind of
I love it.
they are
And I like
write rules for everything that, because like you said, it's based on syscall. So is it something that we use? Usually we say Portuguese that syscalls don't lie. Like if something happens, you will be able to see on the syscall to survive. So there is no way uh, to will not be happening right now. So right now we have Falco, that's something that detects at runtime level, and if we can have the ability to put this kind of runtime detection inside your CI/CD pipelines. So that's the stuff that we want to share with you today, because for example, if you have an action created by Igor, who's like a malicious guy that wants to steal your money in Solace, and he put something, he created an action, and he made some Instagram with alias, and he's trying to make everyone to use this. So how we can detect in real time what this specific action is doing inside your CI/CD pipeline? So we have a project called Falco Actions. It's inside the Falco organization. So if you want to take a look, you can go to the GitHub. Is it inside the Falco organization? But basically the idea is before you start your normal steps, your pipelines. So for example, we have a pipeline to build a Node.js Docker image. So you do the checkout usually, and when you install the Node.js version and you run some npm install or yarn install, Node.js so. And you install the dependencies and you build the image and you do all of this stuff. With Falco, you can start Falco before your normal steps, and you can run everything and then stop Falco. At the end of this, you will receive something saying, okay, something wrong is happening inside this pipeline, like for example, the dump of memory. So if you have an action and this action specific is trying to dump the memory, it's not the usual behavior. So it's not something that we do because you need to have this. So with this action, you can detect, like for example, one of the most common attacks is trying to get the GitHub token. So we can do a lot of things with this token. Or you are trying, for example, to override the source code and put a malicious script. So you can write some custom rules specific for your use case, and you can run inside your pipeline. And at the end, if you fail or not, based on the rules that you wrote. So does it make sense? So the idea here is we have some security actions that we can put inside the pipeline. We have a lot of tools, but our idea here is to cover the runtime at the runtime level. So the idea is everything that's happening, and like Igor said again, most of the company, like the enterprise company, all of their pipelines are running inside self-hosted runners, so they prefer to run their own machine. So it's a point of failure that someone can get this machine and access some stuff inside your company. So that's why we are trying to understand what is happening at the runtime levels. So basically we have two modes to run this action, have some kind of demo here, and I hope I have some enough time. But the idea, the first way to run this is like the basic one. So we just start the Falco, 100 steps, and see at the end if it's failing or not based upon the rules. And we have the second way with this fancy OpenAI. Because if you want to talk about AI, see if you have AI too. That's right.
So that's what be here.
So the idea here is at the end of the pipeline, it will be generated a capture file. Like it's a file that you can analyze all of the syscall that happens during your pipeline, and you can use, for example, OpenAI to generate some report, summarize, and get you the right information. And you can use VirusTotal to get you some information about, for example, this specific action is downloading some dependence from this IP, from this NES. What is their reputation? Is it something malicious or not? So this can give you a complete report about everything that's happening at runtime level. the minting out the network, or you can do it.
No, I just want to highlight from the TJ action example that we were speaking about. Imagine that before had that problem, the action was basically changing a fire pair. So it would trigger a couple of syscalls. One of that is in order to actually change a file under the hood, you are creating a new file and deleting code one because there's no concept of updating a file inside BIOS. So before the action was only create files and delete files, right? After the day that the attack happened, the action would immediately start to also trigger another syscall, which is memory depth. So even if you don't know what a memory depth is, or if you had no idea on how harmful that can be for an environment, you will see in the summary there, oh, in the last 30 days it was just doing 2 or 3 things, and now it's doing this memory dump thing. So let me take a look at what a memory dump is, and then you will know immediately that there's something wrong. You might not know how it happens, how it changed without changing the tag, because that specific attack, they didn't just release a version. He created a specific version that was already working with the malicious code. So you don't need to do any change in order to be attacked by his malicious code. And in this case, in this stack here, we would literally see that the memory dump happened, and then Bubu takes an action. That's the idea of how the Falco action is. And under the hood is pretty much an action that will start Falco if you make sure that it runs in the background so that you can still have it running even if another step takes in place for the GitHub execution. And then it stops Falco by killing the process and generating the scap file, which can be read by Stratosharp. How many of you have used Wireshark before for network packet transition? Yeah, so there's a software, it's called Stratosharp, which was created by the same creator of Wireshark, where you can do the same, but instead of expecting packets, you would expect systops. And this guy also works for sysd, so we are trying to now combine all those tooling all together.
Yeah, awesome. We have our repo here. We can show basically how this action works, and then we can wrap up with some tips. I don't try to share here. I do not have a video, so I don't words, but that's the cycle. So basically, like I was saying, are you able to see? I have a lot of keyboards here, like you can see here. But basically what I was saying is we have 2 modes, like I said. One is for detection the issues at the live mode, and another one to analyze, like to generate a report and show to you what is happening. But here we have an example. It's also workers all in this GitHub Actions workflow. And basically, like I was saying, we have one specific step that is here for start here Falco. So Falco, basically, we are just download and starting the binary to run. And I have the mode here, the version. And here I have, for example, a malicious command that I'm trying to get the GitHub token. And like we can have like a lot of other steps. And here we basically stop the fall. So if we go here, like example here should be one. So basically we have like 2 steps that is the guys. But so we have some jogs here. The yield in at the end, Miami Edward. We have a report with all the events and were detected by. Oh, so as you can see here, for example, we have a rule, call it grab quality type secrets, and basically is the backing that someone It's searching for key drop sequence. So all of these rules here are customized rules. So basically you can create the rule that you bid or you want. And we have here all of the details about this side of code. So with this you can customize and like say in my organization this kind of stuff cannot happen inside our pipeline. You can convert this to a specific rule and inside the pipeline you can detect this. And the other way that I was talking about it's the analyze mode. So basically we have that bit here more information. So for example, we have the process that are running inside this specific pipeline. So we have a lot of process here, and we have, for example, the contact IDs. So we can see if this specific actions is trying to download something from some like weird place. So you'll be able, or your security team, or everyone that needs to pull this, you'll be able to see what is happening inside your pipeline. So talking about the actions, it's not that easy to use. So basically you have two steps and you can configure. So if you go to the repo, we will be able to see the inputs for every type of the action, because we have just two type of the actions and you can use inside our pipeline. And definitely it will give some good information. And it's another project that it's always waiting for some contribution. So someone want to contribute, definitely it's something that can open an issue or talk more about it. Yeah, like you, that's all that I have for the demo. You go the last one.
Just a quick thing on the action. Something to know is that you don't need to know about the rules. So you were seeing the rule here, like saying someone tried to sprint specifically. It's okay, and you don't need to know all the possible ways that someone will try to attack you. As part of the rule, can I go to the full rules that we have here? As part of the action, we do have a set of default rules that if you want to use it without knowing about security and all, there will be a lot of rules already loaded for you. And all those rules, they were created by the Falco maintainers in the community. And what they're trying to do here is making sure that whenever a new attack appears or a new way of hijacking stuff appears, they will update here. And as you can see, it's a little bit verbose, right? Because as I said, syscalls are very low level. So in order to detect that someone changed a file, let's say etc shadow, it's not that easy saying, for example, okay, whenever someone reads a file, go to file. Because you actually need to speak in the syscall level. So you might need to say that the process execution staff file direct to the record has changed, and there's a lot of ways of reading and writing those rules. So the idea is if you got the expertise and want to configure something specific, you can, because it's a default language here. And after you start to play with it, it's actually very straightforward. And also, if you don't want to play with it at all, you can just use the default set of rules, and that should be enough to notify you for the majority of attacks that are happening right now. You might be bloated with a lot of information, and at some point in time, someone will call you at Friday night saying, oh, there's someone attacking the company, and it's actually a false positive. But when there's actually someone attacking the company, you should be notified. The full set of rules is almost comprehensive, as in it can detect the majority of the attacks that happens right now, including the TJ actions, including the solar reads, and there's a couple others, as you can imagine, including the recent one that happened here in Brazil, right? The Pix one. There's still people investigating that, and we even know that the guy he sold the password for 15,000 reais, which is insane. But I'm sure that people will discover that there's also cybersecurity in bomb repair. It's not only social engineering, right? And here we have some tips to how to avoid this, because usually after we give it this kind of talk, some people will leave here thinking that they will be hacked after a minute. There's indeed a lot of people trying to do right now. There's a lot of people with the same knowledge as us that works for the bad. We work for the good, but they work for the bad. And sometimes they own even more, they are the kind of guys that will use it, Kali Linux and whatever. But here are some recommendations for the ABC here. So first thing, always use commit chess when downloading something. Like if you are to load a binary, if you are to load a specific domainers of navigation, how many of you are developers here? Okay, yeah. Imagine that you are downloading the payments. Always think to the shop. Do not pin never to the branch because that's not production ready, let's say, because the branch can change at any time. And also never point to the tag because even though the tag supposedly doesn't change, someone can always recreate the tag with malicious behavior. So always use the commit SHA. The commit SHA is the only thing immutable in regards like the default system. So always use commit SHAs for everything. If you are doing a Terraform model, use the commit SHA. If you are doing a whole dependence, use SHA. If you are using a specific GitHub actions, very specific GitHub actions, always use commit SHAs. That's the first thing. It might be a little cumbersome because all the times that you need to update something, you actually need to update something. You need to go there and change the SHA. And if you are using, for example, a branch, you always keep up to date or even a tag. I'm sure that at least one time in life, everyone created something here pointing to latest, which is kind of fun, right? But don't do that in production. Second thing, there's a lot of things right now like dependables. Probably if you know it, one of the dependables, the thing that keeps stinging you inside GitHub.
Juliana poking a lot of PR that you never hear.
Yes.
But yeah, they exist.
Yes, and it's actually very doubtful. You might be sad sometimes how to execute this again when it's actually really doubtful. So especially when you are using SHAs, because you are always in the oldest version possible. If you don't do anything, the commit shall just get older as the time flows. So having commit SHAs and some solutions like dependables or renovate and like Cerebral CIs has another solution for this. Same for Bitbucket. I'm sure that any CI/CD provider nowadays have one solution for this. So use commit SHAs and then dependable to make sure that you are not in the latest, but you are at least in up-to-date versions. Because all the attacks that we scope here today are all about people introducing change in code, right? But there's also the attack which is someone knows that a specific action is using, let's say, SSH in version XYZ. And then today someone discovered that SSH into that specific version XYZ has a vulnerability. So before people have even time to go there and bump the version, all the hackers will be all the way trying to hack all the fix that depends on that SSH version. So being on the latest is not good, but being in the oldest is also not good. You must be in the intermediate, and having the dependable to allow you to just bump to the newest OK version, it's always good. So here it's very specific to GitHub actions, which is speaking about the variations assigned to become broken, but that also applies for any other CI/CD provider. I have experience with Simple CI. It has even the same name, it's Simple CI token, and it's basically saying what kind of permission that token have. So imagine that you are in an organization and you are a maintainer of one repository inside that organization. Depending on how you configure that token, and it also depends on the organization size, you might be able to just collect information from other repositories that you might not even have read access because that token would have too much permission. So always make sure that if you are just downloading calls, which is usually the minimum, right? You use the checkout action to download the little bits of code. Make sure that the token would have just access to read the code. It doesn't need to have access to push stuff to GitHub registry. It doesn't need to have access to your book. Whatever. Just make sure minimum permissions. That will save you a lot of time as well. And if you can do it, and also usually depends on the structure of the organization, try to use self-hosted runners with some network boundary. Because, for example, in the example of the TJ actions, no data was being sent out. All the data was being pinned there, and in order to actually conceal the problem or the secrets, someone must go to the repository and read the logs. But in most of the attacks, what they do is they dump the memory, they do whatever, and whenever they get access to the data, they will try to send that to an IP in Russia or Ukraine or whatever. So if you can have self-hosted runners with limited a network around it, allowing, for example, just to send data to a specific set of IPs, that will also save you a lot of time.
Awesome. I think we are about us on our side. So if you have any question or any concern or anything that we want to discuss, you'll be here. So yeah, I think that's all. Thank you so much.
Anyone want to ask if there's oil? Yeah, I'll watch your shit.
Yes, I have the question. I can answer one thing. When I elected the GitHub action first in the self of the runner, I don't know, overall and no, overall and unsafe sensor or what components activate when the ETA action.
You can ask in Spanish to prefer if you understand what you're
Yes, cuando yo ejecute la guía action, ¿qué instala en el radio? ¿O qué enciende? ¿Un sensor? ¿O only with the log of the action? What works the sensor?
Yeah, it's a sensor. So Falco is pretty much in the context of Git batches. Falco will be a system B kind of system. So as part of the action, go download the binary and go execute the binary. If they start action and then if they stop action, we'll queue that process. And then before the process is killed, it generates the scap file, which is the output of this.
Well, Falcon only work in self-hosted runners like VM machine, Linux, and Windows, but you know ARC, ARC, Action Running Control.
Yes.
You know, yes, it is a runner, ephemeral running in both in intro Kubernetes, Action Kubernetes cluster. So Falcon don't work into ARC or
Does work, but it depends on, for example, if you have a self-hosted runner, one of ways of installing it would be just as a process, and then whenever the action run, the binary will be already there. But then when you run that ephemeral host, you want to wrap in this, we will execute that as a Docker binary. So we just execute as a container, and then we'll be mounting volumes of far so that we can share from the host to the container. But essentially, it works in any environment because it can run as a container image. So for example, there is a software for VBA which is meant to run CI/CD pipelines inside of Git release, and you can also use this as part of this kind of workflow. You can execute it everywhere. If it has support, I think there's a couple of your OS right now that keyboard support in Falco, but they are very, very specific. But I know that they are trying to do AI native duties right now, so you might not be able to run that in, for example, AWS Reptile, if you ever use that. So depends on really the OS architecture, you know.
Okay.
It doesn't matter if it's September or not. Mostly matters about the architecture of EOX. So
Yeah, pretty much.
Oh no. He talked about the vulnerability in the actions GitHub, and he said that there is a way that you can detect the sequence of syscalls that are being called within a pipeline or an action. So my question is, if of course you use something different or some syscall that you're not expecting on the Python, you're going to alert or execute the or cancel the execution. But can we take this so to our next application in which we know what syscalls are we expecting, for example, from a script application? There is a way in which Falco can learn these syscalls that an application is using, and if it detects something different or an anomaly, it's going to alert.
there's a question. No, there's nothing like that right now. And I think there's something being done as we speak in terms of having some kind of machine learning on the correct Falco output. So that it can say, for example, oh, the last 6 months this application was doing XYZ, and now it's doing XYZ and something else, you know. But right now it's very deterministic, you know. So and also there's for classification for the tools. So for example, if you are deleting a file in your home users, that's something that is harder, right? But if you are trying to delete a binary under user/it, that's probably someone trying to do something weird, or is someone that did something wrong. But we have levels of the issues, So what we usually do in order to avoid the noise as we call it, is to first pay attention to the high ones. If someone is trying to memory dump something, it will be a high one. If someone is trying to get the indice shadow, it will be a high one. If someone is trying to build something that's really dangerous, it will be considered as a level risk of fruit. But if someone is just trying to delete a file or anything that's just daily business, it will be still captured, but it will be a low one. So usually what we do is create the system, and then we have other stuff in the ecosystem to visualize this Falco science key. But the idea is take a look on the events on a daily days. Whenever there's something that's standing out, then go there and take a deeper analysis. We don't need to go every day and see. Let me see all the syscalls that are happening in my cluster. You're gonna be bad first. So the idea is just take a look at the high ones, and the same applies for the pipeline. Memory dump, for example, is a high there. When that happens, you must take an action. Okay, but there's no machine learning for this. Not yet.
Maybe the future. Yeah.
Maybe the future, yes.
You can just hire a guide for your machine learning.
Oh, this is really PhD. Sorry.
But yeah, thank you so much. One more question. I think I'm seeing a lot of folks who are here, but no one is.
Wait for one of you here in depth exam. We will.
Yeah. The next game.
Sorry.
My question is, what's the overlay of maybe to copy your talking direction?
Okay, it's about copyright of the direction. So we have if you go through our falco.org, we support most of the host type people set. And for example, we are installing in a Kubernetes cluster, we support F#. And for example, if you want to just start host default builds on the F#, you could ditch license. We have some good recommendation on the documentation. And if you use the default variety, we start with define. But definitely, if you have something specific for your environment, we have a Slack channel on the Kubernetes Slack channel called Falco, and you can just ask. But basically, we support Git host, most of the package for RDN and Ubuntu and Debian and this kind of talk. So I think you can, if it's not something specific, we can see on our application. But I can share. Some nice. Yeah. Now, that's all.